Welcome to Cloud Infrastructure class. This is week 1, Introduction to Cloud Infrastructure as a Service, part 1. This week we will start with reviewing cloud computing definition and enablers. Next, we will talk about cloud service models, including on-premises, infrastructure as a service, platform as a service, and software as a service. Finally, we will talk about cloud deployment models, including public cloud, private cloud, on and off premises, and hybrid cloud. Cloud computing and its enablers. These days, IT organizations are going through a paradigm change. They depart from the traditional model of running computing centers equipped with specialized and expensive computer hardware and software, which require regular costly maintenance and upgrades. The new paradigm IT organizations are looking at is cloud computing. Cloud computing refers to the creation and use of remote virtual servers or other devices over Internet instead of using local servers or devices. Here is the definition by the National Institute of Standards and Technology, which you may remember from another EDX class. Cloud computing is a model for enabling ubiquitous, convenient on-demand network access to a shared pool of configurable computing resources, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. The two technologies, advances in which in the last few decades made the paradigm change possible, are virtualization and Internet networking. Virtualization refers to emulation of various types and configurations of computer equipment using clusters of standardized hardware components. A special hypervisor software makes these machines or hosts run multiple instances of guest virtual machines which share resources of the hosts. Because hypervisor is a piece of software, creation and control of virtual machines can be done programmatically. Other IT hardware resources like storage and network can also be virtualized. Regardless of where the underlying hardware is located, those virtual resources can be both created and accessed remotely over the Internet. The data centers implementing the cloud can be owned and maintained by the cloud providers in their own separate locations or by organizations on their premises. Virtualization and the Internet are cloud computing enablers. They allow for delivery of elastic, on-demand, pay-per-use IT system configurations in the cloud. Enter the cloud computing revolution. It is estimated that by 2018, at least half of IT spending will be cloud-based, going even higher in subsequent years. This is based on a Forbes magazine article. It does not mean that the traditional IT departments will die, as some say. Rather, their role is being redefined to accommodate creation, configuration, and utilization of cloud environments using various deployment and service models. Also, not all applications can be moved to the cloud. For example, many organizations will prefer to run their mission-critical applications on premises, so there will be always room left for traditional deployments. Cloud service models. Cloud services can be delivered to the customer using several service models. Service models differ by what components of the hardware-software stack are maintained and managed by the cloud provider and which by the customer. This is a summary slide illustrating all cloud service models we will be discussing. Blue elements are managed by you, the customer, and green by the cloud vendor. Traditional deployments of IT systems are done on customer premises, and all components are maintained and managed by the customer. But it also applies to the private cloud delivery model, where an organization maintains an on-premises cloud to take advantage of cloud computing paradigm, but they retain full control over the whole stack. In infrastructure as a service model, cloud service providers make virtualized elements of physical cloud infrastructure, servers, storage, networks, and such, available to the customers. Because the provider implements the virtualization, they also own the virtualization layer. After provisioning virtual resources using the web provider's web portal interface, customers access the user interface screens of those resources over Internet. For example, servers running Windows can be accessed using Microsoft Remote Desktop, servers running Linux using a secure shell command, SSH. When accessing virtual servers using the operating system dependent utilities, customers see the home screen of the underlying operating system. The maintenance of the operating system and all the software running on top of it is up to the customer. Those elements can include middleware, like a web server for developing web applications, runtime of the application platform, for example Java Virtual Machine, and the data and application itself. Exploring infrastructure as a service model will be the topic of our class. The platform as a service model provides the customer with a complete development environment or platform in which they can develop and run their own applications. The platform may include programming language editors, compilers, runtimes, and also middleware and development lifecycle supporting tools like requirement maintenance software, software design tools, testing and deployment frameworks, etc. In Platform as a Service model, customers can implement complete software development pipeline in the cloud and even integrate it with IT operations in a powerful paradigm called DevOps, Development and Operations, which is becoming very popular these days. Customers develop applications and provide data for them, and everything below is up to the cloud provider, which licenses and manages the operating system and middleware. The screen a Platform as a Service customer sees is usually a console which allows for utilizing various elements of the platform. In Software as a Service model, customers simply access a particular application package running in the provider's cloud. The screen they see is only the screen of the application package, and the provider maintains the whole stack, including the package. Also, some cloud vendors implement just a particular resource or service access in the cloud, like storage or database, which leads to new acronyms like Storage as a Service or Database as a Service, and an umbrella model of Everything as a Service.